Hey everyone, this is going to be a longer video than usual because I'm not here today, and I want to make sure that you guys understand how to do the factoring polynomials. Again, we've been kind of covering this over the last few days. We had quite a bit of time in class yesterday to talk through these, and if you had questions to come up and ask. But I know that there were some that probably you didn't get to until after class was over, so I want to actually just kind of go through these real quickly. If you would get this review out. And also, Mr. Bingham is going to hand you the solving polynomials equations by factoring note sheet, because that's what we're going to jump into right after this. So anyways, I'm going to go pretty quick because if I didn't, this would be an extremely long video. And I know you don't want that, neither do I. Hopefully you'll have a little bit of time to work on your homework in class when these notes are over. So let's go through this pretty quickly. Again, you're supposed to factor, and we talked about three different types: two terms binomials, three terms trinomials, and then four term polynomials by grouping. So we're going to kind of hit these, and I'm going to hit it pretty fast, hit it pretty hard. So this one obviously is a binomial. There is no greatest common factor. So what should stand out to you guys right here is this 3. See that 3 right there is representing the fact that that's a multiple of 3. So the only thing I'm even going to check here is to see if it's the sum of cubes, because that's a multiple of 3, and there's no GCF. So is 8a cubed a perfect cube? The answer to that is definitely 2 times 2 times 2 gives me 8, and then of course a. And then 1 is also a perfect cube, so this is definitely the sum of cubes. So it factors into a binomial times a trinomial. The binomial is made up of those two values, 2a and 1. So then, of course, step 2, we squared those. So 2a times 2a was 4a squared. 1 times 1 was 1. So those are my outside. My middle term of that trinomial is a times b. That's 2a times 1, which is 2a. And then, of course, the signs is the last thing we need to do. If the original was a plus, so is the binomial. And to offset that, this had to be a minus. And then, of course, this was always a plus. So there you have it, 2a plus 1 times 4a squared minus 2a plus 1. Can't do anything with either of those. It's done. Let's move along. Number 2. Again, there's no greatest common factor here. Nothing goes into x to the fourth and 100y squared. So the first thing that should pop out after that is that's a 4 and that's a 2. Those are multiples of 2. The only thing that we factored binomial-wise that has multiples of 2 is difference of perfect squares. So is this difference of squares? Well, it's definitely difference. See that minus? So x to the fourth has to be a perfect square because it's a multiple of 2. And then let's check 100y squared. What will multiply by itself to get 100? Well, 10 will. And then y squared, y. So this is definitely difference of squares. Remember, that's the one time that a binomial will break down into two binomials. And those two binomials are made up of x squared times x squared. That's what gives me x to the fourth. And then 10y times 10y. That's what will give me 100y squared. And what's the rule with difference of squares? Plus and minus. Done. I can't do anything else with those because if you notice, those y's are not special. They're just y's. They're not perfect squares. They're nothing. So we're done. Number 3. This, again, no greatest common factor. I see this multiple of 3. I think to myself, is this difference of cubes? Well, m to the third definitely is a perfect cube. How about 64? Sure enough, it is. 4 times 4 times 4 is 64. So this breaks into a binomial times a trinomial. M multiplies 3 times to get m cubed. 4, like we said a second ago, multiplies 3 times to get 64. So let's square those. M times m squared. 4 times 4, 16. And then m times 4, 4m. Last thing, signs. If that's a minus, so is the binomial. And to offset that, this has to be a plus, and this is always a plus. And there you have it. Nothing we can do with either of these. It's done. All right, moving along. Number 4. Number 4, hopefully what you notice, this is a 5, right? This is a 1. So I can definitely pull out a W. But how about numerically? Will something come out of 27 and 75? Well, 3 does. So I can pull out 3W. 3W. 27 divided by 3 is 9. W to the 5th divided by W is W to the 4th. Negative 75 divided by 3 is negative 25, and the w's cancel. So 3w I can't do anything with, but hopefully you notice this right here, that's a multiple of 2. 4 is, right? Multiple of 2. So is this difference of squares? Absolutely. So it is going to break down into a 2 binomials. So binomial times binomial. What multiplies by itself to get 9w to the fourth? 3w squared. 3w squared. What multiplies by itself to get 25? 5 and 5. Last step, signs have to be the opposite, so plus minus. All right, let's keep on rolling. Here, I can definitely pull out no number, but I can pull out a c. When I pull out a c, that's 125, c to the third, plus the c cancels, d to the third. So hopefully, again, you see these are sum of cubes. I'm not going to spend quite as much time moving forward because we've pretty much done all these binomials. This is sum of cubes. So a binomial times a trinomial. What multiplies by itself 3 times to get 125? That's 5c. D multiplies by itself 3 times to get d cubed. So now let's square those. 5c times 5c, 25c squared. D times d, that's d squared. 5c times d is 5cd. If the original was a plus, so is this, and this has to offset that. And there you have it, done. Number 6. This one tricks some people. You really need to pull out a q to the fourth. If you pull out q to the fourth, that leaves you with p to the sixth minus q to the third. Those are both multiples of 3, and it's subtraction. So this is difference of cubes. So it will break down into a binomial times a trinomial. What will multiply by itself 3 times to get p to the sixth? That's p squared times p squared times p squared. What will multiply by itself 3 times to get q to the third? That's just q. So square both of those. What's p squared times p squared? P to the fourth. Q times q, q squared. Multiply those, that's p squared q. If the original was a minus, so is this, and this has to be plus to offset it. Oh, and this is always plus. All right, number 7. Obviously, they're definitely divisible by 5, so pull out that 5. That leaves me with a to the fourth minus 245 divided by 5 is 49. So once again, this is difference of squares. So it's going to break down into 2 binomials. What multiplies by itself to get a to the fourth? A squared. A squared. What multiplies by itself to get 49? 7. What's the rule? One's plus, one's minus. These are done. There's nothing more you can do. Number 8, last binomial. I can definitely pull out 10. Look, this has 8 x's. This one has 2. I can pull out x squared. This has 2 y's. This one has 5 y's, so I can pull out y squared. So my GCF is 10 x squared y squared. So what does that leave me with? Well, 10's cancel. X to the 8th divided by x squared is x to the 6th. Y squareds cancel. Positive 80 divided by 10 is positive 8. The x squareds cancel. Y to the 5th divided by y squared is y cubed. Well, those are definitely multiples of 3. So this looks like sum of cubes. Yes, 8 is a perfect cube. So sure enough, this is sum of cubes. So it breaks down into a binomial times a trinomial. What multiplies by itself 3 times to get x to the 6th? X squared. See, 6 divided by 2, or 3, 2. What multiplies by itself to get 8y cubed? That's 2y. Square those. What's x squared times x squared? X to the fourth. What's 2y times 2y? 4y squared. What is x squared times 2y? That's 2x squared y. Rules? This is a plus. This is offsetting that with a minus. This is always a plus. Done. And that is how you factor binomials. Okay? Now let's move along to 3 terms. 3 terms could take a little bit longer on some of these factors, but I am going to move pretty quickly because you've seen these methods before. So these methods are not new to you. Okay? First of all, there's no greatest common factor here on number 9, so I'm going to try to factor it down into two binomials. Right here, to get x to the fourth, that's x squared and x squared. To multiply to get a negative, that's a positive and a negative. Doesn't matter where I put them. So we're looking for the two numbers that will accomplish two things. Multiply to get 63, have a difference, because those signs are opposite, have a difference of 2. So that is 9 and 7. 9 and 7 will accomplish what we want it to accomplish. So the last thing I look at is right here, this plus sign wins the middle. So plus has to go with my bigger factor. That's the 9. So it's x squared plus 9. It's x squared minus 7. This one cannot factor any further, so it is done. If you have a question about why you think one goes further and it doesn't, make note of it and ask me tomorrow. Okay, this one, no common factor. So let's go ahead and start trying to break it down into two binomials. What multiplies by itself to get a to the fourth? A squared. What multiplies to get a positive? Well, that's either two positives or two negatives. So I look right here, it's got to be two negatives. So we're looking for the two numbers that will multiply to get 2, and they'll combine, because those signs are the same, they'll combine to get 3. Well, it's definitely 2 and 1. That's the only thing that will even multiply to get 2. So it has to be that. Now, this is the first one we've done where we factored it, but it's actually still not completely factored. Do y'all see why? It's right here. That is also difference of squares. I hope you said that. If you said that, cool. If not, say it next time. So we have a squared minus 2 times, this is going to turn into two binomials. So that's a, 1, 1. What's the rule? Plus, minus. Done. Number 10. Oh, flip it over. Let's go to the back to number 11. Well, hopefully you guys notice there's no numbers that come out of all three of these terms, but there is a variable, x. So that leaves me with x squared minus 12x plus 36. So we're going to factor that into two binomials. What will multiply by itself to get x squared? X times x. What multiplies to get a positive? Either two positives or two negatives. This tells me it's two negatives. So they're combining. What numbers will multiply to get 36? Combine to get 12. Again, if you need to go through the factors of 36, go right ahead. That's 1 and 36. That's 2 and 18. That's 3 and 12. That's 4 and 9. That's 6 and 6. The only ones that will combine to get 12 is 6 and 6. So my factors are x times x minus 6 times x minus 6, or I wouldn't have minded if you'd written x times x minus 6 squared. That would have worked as well. You don't have to worry about that if you don't want, but you could have done that. Number 12. Hopefully you see that this definitely has a common factor, 2. Pull it out. If we do, that leaves me with m to the fourth minus 5m squared minus 14. Divided everything by 2, essentially. So we're going to try to factor that trinomial, leave the 2 be, and let's try to break this down into two binomials. What will multiply by itself to get m to the fourth? M squared. What multiplies to get this negative right here? A plus and a minus. What multiplies, what multiplies to get 14 has a difference of 5? Well, that's definitely 7 and 2, right? It's definitely 7 and 2. That's the only thing that will multiply to get 14 and have a difference of 5. So my last thing is, what sign dominated the middle? Well, minus did. Minus dominated the middle. Minus has to win. So minus has to go with my bigger factor. That's the 7. So it's m squared minus 7. It's m squared plus 2. You can't break any of those down any more than that. So there you have it. That's it. All right? Number 13. Number 13, you definitely need to pull out a 5. Can't pull a variable out. They don't all have variables. So that leaves me with x to the fourth minus 2x squared. And then 315 divided by 5 is 63. 63. So let's try to factor that trinomial. two binomials. X squared, right? We go with that. What multiplies to get a negative, positive, and a negative? So they're working against each other. So we're looking for the two numbers that work against each other, have a difference of 2. Well, that's got to be 9 and 7. I think we just did this, a kind of a same problem just a minute ago. Last question, what sign dominated the middle? Minus. So minus has to go with my bigger factor. Which one's bigger? Well, definitely the 9. So it's got to be x squared minus 9. It's got to be x squared plus 7. Now, because of that fact, y'all notice something? This is what we call difference of squares. That's right. Whoever just said that, and I really have no idea if you just said it because this recording was done yesterday. For you, it's done right now for me. X squared plus 7 I can't do anything with, but x squared minus 9 is difference of squares. So that's going to break into two binomials, and those binomials are x and x, 3 and 3, plus and minus. All right, y'all should be rolling in these now. It shouldn't be that hard. All right, number next. It's number 14. Will something come out of all these? Well, definitely the u, right? Definitely the u. But what about 3? Won't 3 come out of them too? So I'm going to pull out 3u. So that leaves me with u to the 4th. Negative 9 divided by 3 is negative 3, and that's going to end up with u squared. Negative 84 divided by 3 is negative 28, and the u's cancel. So here we go. Let's try to factor that into two binomials. Definitely going to be u squared, right? It's got to multiply to get a negative, so it's definitely going to be plus and minus. So we're looking for a difference of 3. What will multiply to get 28 and have a difference of 3? 4 times 7. 4 times 7. It's got to be those two numbers. So my last thing is, how do I know which one it is? Well, look at that minus sign. It wins. If it wins, it has to go with the bigger factor. That's the 7. So it's u squared minus 7, and it's u squared plus 4. Now, if those would have been switched, I would have been able to break down u squared minus 4. But as it is, I'm done. I can't break down the u squared plus 4. That's not difference of squares. And I can't do u squared minus 7 because that's not difference of squares. 7 is not a perfect square. So there you have it. It's done. Number 14. Number 15. Number 15, you're going to try to break all this down. And when you break all this down, you are not going to be able to pull out any common factors. So we're ready to just jump straight into factoring a trinomial into two binomials. Now, fortunately for me, I know the only thing that will multiply to get 3a to the 4th is 3a squared and a squared. So that's good. I don't have to do a lot of thinking. Here's where the thinking has to come in. To multiply and get a positive, remember what the rule is? They're either both positive or they're both negative. This right here tells me they're both positive, okay? Got it? Here's where it gets a little tricky though. Think of all the things that you can multiply to get 20. You don't have a ton, but you got 1 times 20, you got 2 times 10, and you got 4 times 5. So you got 3 different possibilities. Now, again, I know what the answer is, obviously, because I've done this problem already. A lot of times we start with the ones that are in the middle, so we might start with the 4 and 5. So I might throw the 4 in here and the 5 in here. But remember that we're looking for a combination of 16. Well, what's 3 times 5? That's 15. And what's 4 times 8? Well, that's 4. 15 and 4 combined to get what? Well, not 16. So let's switch these real quick. Try the 5 here and the 4 here. What's 3 times 4? That's 12. What's 5 times 1? That's 5. 12 and 5 give me 17. So I'm super close, but it's not accurate. So it's not 4 and 5 at all. We tried it both ways, and it doesn't work. So let's go back. Let's get rid of those. My next ones I would probably try would be 2 and 10. Well, if I do 2 here, 10 here, well, 3 times 10 is 30. I'm already way over. So let's switch these. And I didn't mean to erase all that. Let's do 10 here, 2 here. What's 3 times 2? 6. What's 10 times 1? 10. What will 10 and 6 combine to get? Bingo. There it is. So it's 3a squared plus 10, which I can't break down, times a squared plus 2, which I can't break down. So we are finished. That is the answer for number 15. 16, very similar. We've got no greatest common factor. So we're ready to try to start breaking this down into two binomials. Here's the deal though with this. What's the only thing that will multiply to get 8? Well, you got 1 times 8 is a possibility. You got 2 times 4 is a possibility. And then on the other side, you've got the 1. Well, that's good because the only thing that will multiply to get that's a 1. So I can go ahead and jam those in. So here's my other thought process. To multiply to get a negative, what's the rule? One of these have to be a positive and one of them has to be a negative, right? So they're going to have a difference of 2. A difference of 2. Well, since these are both just 1, that kind of helps me, doesn't it? Because they're not going to affect the first terms at all. Think about it. What would happen if I multiply by 1? Nothing. What will happen if I multiply by 1? Nothing. So what I use over here has to have a difference of 2. Well, there it is. It's got to be 2 and 4. Since this is into the fourth, it's going to be 2n squared and 4n squared. All right? And here's the last thing. What sign won the middle? Negative did. So negative has to go with my bigger term. And which one's bigger? The 4 is. So where can I make the 4 a negative? Well, the multiplication was there, so I need the negative there. So this is going to be plus, which means none of these will factor any further. 2n squared minus 1, those are not difference of squares because 2 is not a perfect square. And the other one's not difference of square because it's not difference. Even though they're both perfect squares, the sign is a plus, so we can't break it down. So anyways, that is factoring with 3-termed polynomials. Now let me go ahead and speed things up. I think the video is probably getting kind of long. So let me do this the 4 terms pretty fast. You guys are pretty good at it. We're going to group. I pull x squared out of here. That leaves me with x minus 2. I always start with whatever the sign is, so that's plus. Since I can't really pull anything out of x and 2, I'm going to pull out a 1. So x divided by 1 is x. Negative 2 divided by 1 is negative 2. These are the same. See? So what are my 2 factors? Well, what did I pull out? X squared plus 1. And what was left inside? X minus 2. Go over here to number 18. Group it. Pull out a 3b squared. 6 divided by 3 is 2b. Negative 3b squared divided by 3b squared. Cancel, so we need a negative 1 there. Whatever the sign is, I always start with it. It's plus. What can we pull out of 4b and 2? I can pull out 2. So I'm going to take 4b and divide it by 2. That's 2b. I'm going to take negative 2 and divide by 2. That's negative 1. Do these values match? Absolutely. So my factors are what I pulled out, 3b squared plus 2, and what was left inside, 2b minus 1. That can't be factored any further. We're done. Number 19, group it. We've got w squared out of this first group. That leaves me with 2w plus 3. We always start with that sign. That's a minus. What can we pull out of 6w and 9? 3. So we pull out a negative 3. Let's see what that leaves me with. Negative 6w divided by negative 3 is positive 2w. Negative 9 divided by negative 3 is positive 3. So my 2 factors are, what did I pull out? W squared minus 3. And what was left inside? 2w plus 3. And then lastly, number 20, group it. I can pull out an x to the third. I'm sorry. I can pull out x squared. What will that leave me? X to the third. And then 5x squared divided by x squared, just plus 5. Always start with that sign. It's a minus. What can we pull out of 4x cubed and 20? 4. So we're pulling out a negative 4. Negative 4x cubed divided by negative 4 is x cubed. Negative 20 divided by negative 4. See, listen, negative 20 divided by negative 4 is a positive 5. So sure enough, these do match exactly. So my factors are, what did I pull out? X squared minus 4. What was left inside? X cubed plus 5. Now, please don't forget that x squared minus 4 is the difference of two perfect squares. So that will also break into two binomials. The x cubed plus 5, I can't do anything with that, okay? I can't do a thing. So here's my final answer. What multiplies by itself to get x squared? X times x. What multiplies by itself to get 4? 2 and 2. What's the rule? 1's plus, 1's minus, and we are done. So there's that worksheet. I know that took a while and was probably pretty boring, but you have to know how to do that because we're moving into what we're doing today. So you have this hopefully at this point. We're going to solve polynomial equations by factoring. And again, this can be challenging, but it doesn't have to be necessarily. We've talked about all the things that we're going to do today. So we've talked about all the ability to factor, but then also solving by factoring means we take our factors, set them equal to 0, and we solve. Now here's the rule of thumb. You got to at least get them down to the x squared region. That'll make more sense in just a moment. But let's go through this and figure it out. Look at number 1. We're going to solve it by factoring. Well, it's a cubic polynomial, isn't it? It's already set equal to 0. You see that? So all I need to do is factor it. Well, it's a binomial, right? 1, 2 terms. Binomial. What's the first thing you're supposed to check when it's a binomial? Hopefully you remember GCF. What can you pull out of both of those terms? X. If I pull an x out, here's what I'm left with. X cubed divided by x is x squared. And positive x divided by x is positive 1. The x's cancel. So have I gotten it down to x squared at least? Look, the x squared plus 1, I can't do anything with that. That's not difference of squares. So I can take these factors now and set them equal to 0. So look, if I do that, isn't the first one already solved? One of my answers is x equals 0. That's it. But how about the one on the right? How in the world am I supposed to solve that? Well, you've done it before. We solve by taking the square root. Look, x squared is the only variable there. So we isolate it. We isolate it by subtracting 1. Then we take the square root of it. Y'all remember what you have to add to your answer because you took the square root? X will equal plus or minus. Now, how does that negative come out of there? As an I. And then what is the square root of 1? It's a 1. So my answers are 0 and positive and negative 1i. 3 answers. 0, positive 1i, negative 1i. Got them all. That's how you solve by factoring. We factored it as far as we could, and then we took our factors, set them equal to 0, and solved. Look at number 2 with me. First of all, don't we need to get everything on one side? So I've got to subtract this 3x squared to bring it over here with this negative 7x squared. Those are like terms. So we're left with 4x cubed. And then what is negative 7x squared minus 3x squared? That's negative 10x squared. So similar to the last problem, what can we pull out of this? 2x squared. Let's see what we're left with. What's 4 divided by 2? 2. What's x cubed divided by x squared? X. What's negative 10 divided by 2? Negative 5. And what happens to x squared divided by x squared? Cancels. So here we have it. Ready? Let's take our factors. We've gone as far as we can. Let's take our factors, set them equal to 0, and solve. There we have it. Those are my factors. Set them equal to 0 and solve. Wouldn't I divide this one by 2? Well, that's x squared equals 0. Wouldn't I take the square root of both sides? Don't I add plus or minus to my answer? Yeah, but do I need to hear? No, because what is the square root of 0? It's 0. There's no such thing as plus or minus 0. The answer is 0. Anybody like to expound on that? If you said with a multiplicity of 2, nice work. Remember, because that exponent is squared, that technically means 0 is your answer. How many times? Twice. So my answer is 0 with a multiplicity of 2. Now let's finish off the other one. We're going to add 5. We're going to divide by 2. That's 2.5, or 5 halves if you want to write it. So 3 answers. 0 with a multiplicity of 2 and 2.5. All right? I hope you guys understood that one. Let's keep on cruising along. Let's look at number 3. I'm going to check to see how long my video is getting. I don't know if I can even see it, though. I can't even see how long my video is. Just hopefully it won't be too long. If it is, then sorry, I'm going to have to stay after class. I'm just joking. All right, so this is difference of what, guys? It's difference of squares. Now listen, you can't take this and try to solve it from here. I know that you could type in your calculator the 4th root of 64, but we're not going to do that. Okay, we're going to at least get it down to x squared. So here we go. We're going to factor this into 2 binomials. So we've got x squared times x squared. What multiplies by itself to get 64? 8 times 8. What's the rule? 1's plus, 1's minus. Here's how this works now. Ready? Let's take those, now that we got them down to x squared at least, and we can't go any further than that, take them and set them equal to 0, and watch how we solve this. This one, on the left, don't we subtract 8? So negative 8. When we take the square root, remember what you add to your answer? Plus or minus. How does that negative come out of the radical? As an I. And if I try to break down the square root of 8, 4 is the biggest perfect square, and it goes in there twice. So this becomes a whole number 2 times the square root of 2. So this is going to be plus or minus 2i times the square root of 2. But look at this one. We add the 8, it's just a positive 8. When we take the square root of positive 8, it's going to still be plus or minus. There's no I this time. It's just 2 square root of 2. So my 4 answers, look up here. How many answers should it have had? 4. My 4 answers are positive 2i square root of 2, negative 2i square root of 2, positive 2 square root of 2, and negative 2 square root of 2. Bunch of answers, but we found them all. All right, let's move along. I'm going to, I need to do it. Let me do this one. We're going to pull out 5x. That's a GCF, and that's an important greatest common factor, guys. Why? Because it has a variable. So leave it there. Don't forget about it. So what does that leave me with? Well, x to the 4th minus 16. Well, that's difference of squares, guys. So that breaks down into 2 more binomials. What are those binomials? X squared, 4 and 4, plus and minus. So let's set all of my factors now equal to 0 and solve. Now, that was supposed to be squared. Sorry about that. Some people might look at this right here and say, hey, that's difference of square. Let's factor it further. You don't have to. If you get your factors down to x squared, you can solve it from there because it's going to be a binomial. So if you get that binomial squared down to x squared, you can just solve these. So here's how we do it. 5x equals 0. X squared plus 4 equals 0. And x squared minus 4 equals 0. This I'm going to divide by 5, so x will equal 0. There's one of my answers. This one I'm going to subtract 4. I'm going to take the square root, so I have to add plus or minus to my answer. How does negative come out of the radical? As an I. What's the square root of 4? That's a 2. So that's positive and negative 2i. That's 2 more answers. And then here I'm going to add 4, take the square root, so it will be plus or minus just 2. So it's going to have 2 answers here. So look, how many solutions was I supposed to have? 5. How many do I have? 5. I've got 0. I've got positive 2i. I've got negative 2i. I've got positive 2. And I've got negative 2. So there it is. Flip it over to the bench. I'm not going to do all these. Let's go over here to number 6. Go to number 6. Number 5 and 6 are very similar. You need to get these on the same side. So I'm going to do that by taking 54 and subtracting it. Believe it or not, 16 and 54 will reduce by the number 2. That's it. That's the biggest number that goes into both of those two. And here's what it leaves me with. 8x cubed minus 27. Now think about this, guys. Is this 2 right here, is this an important factor? Not for what we're doing today. Here's why. We are solving by factoring. So since that is not got a variable, it's just not important. So let's focus on what is important. This is difference of cubes, which will factor down into a binomial times a trinomial. So that's 2x and 3. So what do I do with that? Well, I square it. What's 2x times 2x? 4x squared. What's 3 times 3? That's 9. What's 2x times 3? 6x. If that original sign was minus, so is the binomial, and this is plus, and this is always plus. Now look at this. This is the difference. This is the difference, and I talked about this the other day actually. If I take 2x minus 3 and set it equal to 0, I would add 3. I would divide by 2, and my answer is 1.5. There's one of my answers. How many more should I have? Well, I should have 3 in all, right? I should have 3. So this right here gives me 2 of them. So here's the deal. How do I solve that by factoring? Do y'all remember the other day when we did this and I told you the trinomial of difference in sum of cubes cannot be factored? So if I can't factor this further, how can I solve it? Well, if you look at your instructions above, this is where quadratic formula comes into play. Remember quadratic formula, guys? X equals negative b plus or minus the square root of b squared minus 4ac, and all of that's divided by 2 times a. So that's literally what we have to do. A is 4, b is 6, c is 9. So here I go. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. That's supposed to be a 4. That's kind of a terrible 4. So let me rewrite it. So here we go. We got negative 6 plus or minus. You need to simplify what's inside the radical. Well, that's negative 108. Negative 108. And on the bottom, you got 8. So let's see if we can't break down negative 108. 108. Let's think. 108. 108 divided by 2 is 54. So don't try a perfect square above 54. 49 won't go into it. 36, hey, there it is. 36 goes in there 3 times. So square root of 36 becomes a 6, and the 3 gets trapped inside. So here's how this reduces, guys. Ready? Negative 6 plus or minus 6, don't forget the negative, I times the square root of 3 over 8. Now, hopefully you guys see this. If you left it like that, I probably wouldn't mark it wrong. But you notice how all 3 of these things, 6, 6, and 8, are all divisible by 2. Since they're all 3 divisible by 2, I'm going to reduce this. My final answer is negative 3 plus or minus 3i times the square root of 3 over 4. I simply divided them all by 2. So my 3 answers are 1.5, negative 3 plus or minus 3i squared of 3 over 4. Those are my 3 answers. Okay? And I know that was kind of intense, but that is the way it's done. Okay? All right, let me do number 8 and then number 9, and then I'm going to give you your work. First, let's get everything on one side. 3x to the 4th minus 2x squared minus 16. This is a trinomial. We're going to factor it into 2 binomials. That's 3x squared and x squared. To multiply to get a negative 16, let's see, we got 1 and 16, 2 and 8, 4 and 4. So I will try the 4 and 4. What's 3 times 4? That's 12. What's 4 times 1? That's 4. Does that have a difference of 2? Nope. So it's not that. So let's try 2 and 8. 2 and 8. What's 3 times 8? 24. What's 2 times 1? 2. That's not a difference. So let's switch them. So let's try the 8 here, the 2 there. What's 3 times 2? 6. What's 8 times 1? 8. Is the difference between 8 and 6 2? Boom. There it is. Now what 1? Negative 1 in the middle. So it has to be negative 8. So this has to be a minus 8. This has to be a plus 2. So there's my factors. Hope you guys see that. Since I got them down to x squared, I'm going to set them equal to 0 solve. Add 8. Divide by 3. Take the square root. So x equals plus or minus the square root of 8 over 3. I'm not even going to ask you guys to reduce that. Okay? I'm just not going to. It's silly right now. Here we have x squared plus 2. Set it equal to 0. Subtract 2. Take the square root. So x will equal plus or minus I times the square root of 2. So there you have it. That's how you do those. That's 4 answers. You got positive and negative square root of 8 thirds. You got positive and negative I square root of 2. And then last one I'm going to do, number 9, and that is factor by grouping. I'm going to factor by grouping because it's 4 terms. So x squared comes out of that first group. That leaves me with 2x minus 3. Always start with this sign. That's a minus. What's the biggest thing that comes out of 32 and 48? Think about that. That's, what, 16. Negative 32x divided by negative 16 is positive 2x. Positive 48 divided by negative 16 is negative 3. So sure enough, these are the same. So my two factors are what I pulled out, x squared minus 16, and 2x plus 3, or 2x minus 3. Now someone might say, hey, x squared minus 16 is difference of squares. And you're right. And you are welcome to break it down. Let me show you. You're welcome to go, that's 2 binomials. That's x and 4. And then you don't forget about the 2x minus 3. Well, watch what happens. If this is a plus and this is a minus, won't I just take x plus 4 set it equal to 0, and x minus 4 set it equal to 0, and 2x minus 3 and set it equal to 0? So this will be negative 4. This will be positive 4. And this will be 2x equals 3. This will be x equals 1.5. Now watch this, guys. Since I did get it down to x squared, if I take x squared minus 16 and set it equal to 0, and 2x minus 3 and set it equal to 0, how will I solve this one on the left? You'll add 16. So x squared will equal 16. You'll take the square root of it, which causes me to add a plus or a minus. And what is the square root of 16? 4. So doesn't that say my answer is positive and negative 4? I already got, that's what I got. So either way. Now here you're going to add 3, so 2x equals 3. You're going to divide by 2, so x equals 1.5. So sure enough, you get the same answer. Look, those are obviously the same. And then these are obviously the same. So you get the same answers. So if you want to take those down one more level, you feel free to do that, but you absolutely do not have to. All right, so I am going to give you as a homework assignment from the worksheet that's coming your way right now. And Mr. Bingham has these numbers, and he can share them with you. It's 1, 2, 3, 4. And then we're going to pick back up at 6, go to the back, and do 7 and 8. And then we're going to pick back up and do number 10 and 11. Okay, so your homework tonight is 1, 2, 3, 4, 6 from the front, so all but 5. So that's 5 problems. And then on the back, 7, 8, 10, and 11. So that's 4 problems. So 5 plus 4, mathematicians, 9 problems. This might take you a minute. So again, do your best. Tomorrow we'll go over it and see how you did. Hope you have a great rest of your day.